Welcome to Course 4, Foundation, Certified Supply Chain Professional, CSCP, course, by SPAO Academy. Topic 2, Global Supply Chain Networks, Section 2, Supply Chain Optimization, Lesson 1, Optimization Methods Overview. Introduction. Welcome to the first lesson on supply chain optimization. In the previous section, we explored the structure of global supply chain networks. Now, we will tackle the question: how do we make these complex networks run as efficiently and effectively as possible? This lesson will provide a high-level map of the different tools and techniques used to optimize supply chains. Learning objectives. By the end of this lesson, you will be able to define supply chain optimization in simple terms, categorize the main types of optimization methods, explain the difference between descriptive, predictive, and prescriptive analytics, identify at least two common challenges in applying these methods. 1. What is supply chain optimization? At its core, supply chain optimization is the process of making a supply chain as efficient and cost-effective as possible. It's about finding the perfect balance between cost, minimizing expenses related to production, transportation, and inventory, service level, ensuring products are available when and where customers want them, risk, building resilience to handle disruptions. Think of it like planning a long road trip. You want to minimize fuel costs, arrive on time, service level, and avoid traffic jams or road closures, risk. Optimization is the GPS that helps you find the best route. 2. The 3 levels of optimization decisions. Optimization happens at different time horizons. It's crucial to understand these levels: strategic, long-term decisions that have a long-lasting impact. Example: where should we build a new warehouse? Which suppliers should we sign a 5-year contract with? Tactical, medium-term decisions about resource allocation over months or seasons. Example: how much inventory should we hold before the holiday season? Which transportation modes, air, sea, rail, should we use for different products? Operational, short-term, real-time, day-to-day decisions. Example: which route should today's delivery trucks take? Which order should we pick first in the warehouse? Different optimization methods are suited for different levels. 3. The analytics ladder, a framework for methods. To understand optimization methods, it's helpful to visualize them on a ladder, from simple to complex. This is often called the analytics maturity model. Level 1. Descriptive Analytics, what happened? Goal: to understand the past and current state of the supply chain. Methods: standard reporting, dashboards, data visualization. Example: a dashboard showing last month's on-time delivery rate was 92%. This is the essential first step. You can't optimize what you can't measure. Level 2. Diagnostic Analytics, why did it happen? Goal: to drill down into the data to find the root cause of an outcome. Methods: data mining, correlation analysis, drill-down reports. Example: investigating why the on-time delivery rate dropped. The analysis might reveal that a specific supplier in a specific region had major delays. Level 3. Predictive Analytics, what will happen? Goal: to forecast future trends and events. Methods: machine learning, forecasting algorithms, regression analysis. Example: using historical sales data, weather patterns, and economic indicators to predict customer demand for the next quarter. This prepares you for what's coming. Level 4. Prescriptive Analytics, what should we do about it? Goal: this is the heart of optimization. It uses data and predictions to recommend the best course of action. Methods: optimization algorithms, linear programming, mixed integer programming, heuristics, simulation. Example: based on the demand forecast, predictive, a prescriptive model calculates the exact amount of inventory to place at each warehouse and the most cost-effective delivery routes to meet that demand while minimizing costs. 4. Key optimization methods, a glimpse. Here is a brief introduction to some common methods you will encounter. Linear programming, LP, a mathematical method used to achieve the best outcome, like maximum profit or lowest cost, in a model whose requirements are represented by linear relationships. It's excellent for problems like, how much of each product should a factory make given limited resources? Integer programming, mixed integer programming, MIP, an extension of LP where some, or all, of the decisions must be whole numbers. This is crucial for decisions like, how many trucks do I need? You can't have 2.5 trucks. Or, do I open a new warehouse or not? A binary yes, no decision. Heuristics. Sometimes, problems are too complex for traditional math to solve quickly. Heuristics are rules of thumb, or shortcut methods designed to find a good enough solution quickly, even if it's not the absolute perfect one. Think of it as using common sense to narrow down the options. Simulation. This method creates a digital twin of the supply chain. You can test different what-if scenarios, e.g., what if a major port shuts down, or what if demand suddenly spikes by 20%, to see how your supply chain would react, without any real-world risk. 5. Challenges in optimization. Optimization isn't magic, it comes with its own set of challenges. Data quality. The output is only as good as the input. If your data is messy, incomplete, or wrong, the model's recommendations will be flawed, garbage in, garbage out. Model complexity. Building a model that perfectly represents the real world is impossible. The key is to find the right level of detail, capturing the essential complexities without getting bogged down. Change management. The people running the supply chain need to trust the model. Implementing a model's recommendations often requires a cultural shift within a company. Summary and key takeaways. Optimization is about finding the best way to balance cost, service, and risk. Decisions are optimized at strategic, tactical, and operational levels. The journey to optimization starts with understanding the past, descriptive, and the future, predictive, to make the best decision now, prescriptive. Methods range from mathematical certainty, linear programming, to quick shortcuts, heuristics, and safe experimentation, simulation. Remember, the most powerful optimization model is useless without good data and user trust. Next lesson preview. In our next lesson, we'll dive deeper into one of the most powerful and widely used methods in supply chain, linear programming. We'll break down the components of an LP model and walk through a simple example. I really appreciate you spending your time with me today. If you want to learn more, don't forget to hit that subscribe button. Your like means the world to us and helps this channel grow so we can continue bringing you great content. Thanks again, and see you on the next video.